Hi everybody, this is Mrs. Valentine. I have a magnificent Monday. Today is April 6th and we're going to learn about negative exponents. Okay, I'm going to ask you to do two things after the lesson. First is to answer the EQ in a summary, and then second, work on IXL Math 8 F9. Go ahead and take out your notebook and let's get started. Remember to pause whenever you need to. I'm going to try to run through this video as fast as I can, so that if you want to look at it a second time, you can run through it a second time and not have to worry about fast forwarding. Okay, here we go. So your title is When to Use Negative Exponents with Division. Your essential question: which expression could be expressed with a negative exponent? So you have x to the sixth over x to the second, or would it be x to the second over x to the fifth? Take the expression you chose and show how you can simplify it using negative exponents. Okay, remember, anything in blue, do not write down. So I want you to recall how the rule for dividing exponents with the same base works. So we're going to simplify each expression using the rule for dividing powers with the same base. And if you forget how to do it, work them out in factored form and cancel. Why don't you pause and take a minute to work out these two problems, and then rejoin me and I'll kind of show you done out the long way. Okay, go ahead and pause and work out these two problems in your notebook. Okay, now that you're back, let's do this together. So if I forget how to do division, I can just go ahead and do this out the long way in factored form. That's the good thing about remembering how to do factored form. 1, 2, 3, 4, 5, 6, 7, 8. You can always reteach yourself the rule if you just work things out the long way with a sample problem where the exponents are not too big. Okay, so I have numbers over themselves. This makes 1. This makes 1. This makes 1. And what I'm left with is 5 to the 1, 2, 3, 4, 5 fifth power, and that's all in the numerator, so I get 5 to the fifth power. On the second one, I have 4 to the fifth power over 4 to the ninth power. Gotta extend that line there. So again, I'm going to cross out anytime I have a number over itself. I can do that since it's all in factored form. So I have 5 pairs of the number 4 over itself. Those all make 1. So the leftover factors of 4 are in the denominator. So I get 4 to the 4th power in the denominator. At the top, 1 times 1 times 1 times 1 is all 1. Could have written this with a denominator of 1 also, but we could then just simplify it as 5 to the 5th. This we cannot. We need to leave it just the way it is. So your rule, I want you to remember and write this part down: when dividing powers with the same... See if you can finish that. Okay, if you've unpaused now, let's go ahead and finish it off together. When dividing powers with the same base, we're going to subtract the exponents. So sure enough, if we did 8 minus 3, we would get 5. And there were more powers of 5 in the numerator in the top, so that 5 to the 5th, those 5 powers of x were left in the top. On the second one, we had more powers of 4 in the denominator, so the difference between 9 and 5 is 4, and we had 4 to the 4th that was left in the denominator. Okay, let's move on. Okay, so negative exponents. Using the division rule, we can look at 2 ways to simplify the expression. So if we have 5 to the second divided by 5 to the 5th, we can go ahead and ask ourselves, okay, where are there more powers of 5, in the numerator or denominator? Okay, right, they're in the denominator. So I know the leftover powers of 5 are going to be in the denominator. And if I find the difference between 5 and 2, okay, 5 minus 2 gives me 3. I'm going to have 5 to the 3rd power left in the denominator, and I need to have a 1 in the top. Well, another way to do it, oops, that should be moved over there. So 5 to the 2nd over 5 to the 5th. Forgot to put a little spacing there. A second way we can look at this is using negative exponents. We can subtract those exponents in order. So we can call this 5 to the 2 minus 5 power. And that's basically working from top to bottom, 2 minus the 5. So that's going to give us 5 to the, who's going to win? Negatives by 3. 5 to the negative 3 power. So these two answers mean the same thing. So what negative exponents let you do is they let you write powers without using fraction form. So again, we could either show that the powers are left in the denominator, 5 to the third, or we could write that without fraction form by just calling it 5 to the negative 3 power. So let's go back for a minute. Which problem from the recall questions that we just did in the previous slide can be simplified with negative exponents? Let's go back and look. So basically, we're trying to see which one of these problems has powers left over in the denominator. Is it problem number 1 or problem number 2? Yeah, obviously it's problem number 2. So we have 1 over 4 to the 4th. The other way to write that would be, let's go back to our original problem, would be 4 to the 5 minus 9 power. That's subtracting them in order. The top one minus the bottom one, which is going to give us 4 to the, who's going to win, positives or negatives? Negative. 4 to the negative 4 power. So these are the same. 1 over 4 to the 4th and 4 to the negative 4 power are the same. One's in fraction form and one is not. Okay, so let's use that and go ahead and simplify each of these expressions two ways. Remember, you don't need to write this in blue. So on this one, we've got n to the 5th over n to the 7th. Let's make it in fraction form first. So where are there more powers of n? That's right, in the denominator. So let's make our fraction bar. The powers of n are going to be left in the denominator. If we subtract to get a positive exponent, we do the bigger minus the smaller. So 7 minus 5 just gives us positive 2. And so we get 1 over n to the 2nd. Or the other way we can do that is taking n to the, let's subtract the exponents in order, the top minus the bottom. So that's 5 minus 7. That would give us n to the 5 minus 7. Who wins, positives or negatives? Negatives win, then win by 2. So 1 over n to the 2nd is the same as n to the negative 2 power. Let's try the next one. So we have y to the 3rd over y to the 8th. We have more powers of y in the denominator. So if we answer this in fraction form, our leftover powers of y are going to be down here in the denominator. How many leftover powers of y are we going to have down there? Well, if we subtract 8 and 3 to find their difference, but we want it to be a positive difference, 8 minus 3 gives us 5. And then we need to have a 1 in the top. So we could write it that way. Or we could take y to the 3 minus 8 power, subtracting them in order, top one minus bottom one, which is going to give us y to the negative 5th power. So y to the negative 5th power is the same thing as 1 over y to the 5th. And then the next one, we have more powers of m in the denominator. So our powers of m are going to be down here. We're going to write this using a positive exponent, so find the difference, the positive difference. So 5 minus 4 just gives us 1. We really don't need to write that m to the 1st power. We really don't need it since it's to the 1st power, because m and m to the 1st are the same thing. What we do need is a 1 on top. Or we can have m to the 4 minus 5 power. Again, subtracting those exponents in order, 4 minus the 5, which is going to give us m to the negative 1 power. So 1 over m is the same as m to the negative 1. Okay, again, don't write the blue. So next we're going to do division, and some of these are going to need negative exponents, some of them are not. We're going to write them so that nothing is in fraction form. So we're going, if we have one that would come out to a fraction, we're just going to use a negative exponent instead. So it's all about finding out where are those leftover powers going to be. So on this one, if we have, would there be more powers in the numerator or denominator? Right, denominator. That means we would put this in fraction form, but we're not going to. We're just going to subtract those exponents in order. So this is going to be 5 to the 2 minus 8th power, which is going to give us 5 to the negative 6th. Okay, over here, would this end up in fraction form? Where do you have more powers of 7? Nope, they're in the top, so it's not. Again, this is 7 to the 9 minus 5 power. That's going to come out positive. 7 to the 4th. Again, the leftover powers were in the top anyway, so no matter how you do this, you're just going to end up with positive exponents and no fraction form. That's that one. So no negative exponents are necessary because it wouldn't be right. Okay, let's look at the next one. Do we have more powers in the top or the bottom? Oh, we have more on the top. So this wouldn't come out in fraction form anyway. That means we're going to end up with positive exponents on it. Let's see. So we have x to the 6 minus 3 power, which just gives us x to the 3rd. Yep. So this one's a lot like number 8. No negative exponents needed. And then how about number 10? Do we have more powers in the top or the bottom? More in the denominator. So this would normally, if we were to keep our exponent positive, we'd have a fraction form, but we're not going to do that. We're just going to subtract the exponents. So we're going to do v to the 8 minus 9 power. So that's going to give us v to the negative 1. So we're writing that with a negative exponent because it would have been one that came out in fraction form. Okay, now you try it. Go ahead and pause for a minute. Try these, and then check back in a second. Okay, now that you're back, let's take a look. So again, we have more power. Where do we have more powers of 6, top or the bottom? We've got more in the top. That means negative exponents are not going to apply here. So we can just take a look and say 6 to the 12 minus 5 power. That's just going to give us 6 to the 7th power, and we are all done. No need for negative exponents. It would not be correct to use them here. Okay, number 12, we have 7 to the 3rd over 7 to the 15th. Where do you have more powers of 7, the top or the bottom? Oh, they're more in the denominator. So this normally would come out as a fraction because we'd have leftover powers in the denominator. That lets us know, okay, this is one where we're going to end up with a negative exponent, which becomes obvious once we subtract those exponents in order. So 7 to the 3 minus 15, that gives us 7 to the negative 12 power. Next one, we have more powers of x in the bottom. So this one also would come out to a fraction. It's going to be obvious that you'll use a negative exponent here when you just go ahead and subtract your exponents in order. So x to the 6 minus the 11th power is going to give us x to the negative 5 power. And then the last one, where do we have more powers of v, in the top or the bottom? Well, we've got more in the top, so this one's not going to come out to a negative exponent anyway. But we're going to be able to see that when we do the exponent. So v to the 18 minus 9 power just gives us v to the 9th. So of course it's not going to come out negative. 18 minus 9, when we do that in order, it just comes out positive. Okay, so that's what we're working on. This